So another thing that you need to know for this exam, and there's just one question and you get to look at the graphs and kind of match them, but you should be able to identify what the graph of a derivative function would look like given the graph of a function. And so, for example, we have, let's say, a horizontal line, y equals 1. And it's horizontal just on the negative values for your y. I'm sorry, for your x. And then you have a vertical asymptote on the right of x equals 0. And it looks like this. So this is your f of x function, and you should be able to graph or look at the graphs and choose which one it is. So let's graph f prime of x. Okay, well, the derivative, that's basically the rate of change, what's happening at each point. And so if you're looking at this piece right here, our slope is always 0. So for our derivative function, we're going to have a horizontal line at y equals 0 on the left-hand part. And then notice that this piece here is always increasing. So this is always increasing. So m is always greater than 0. F of x is always increasing. And so that tells me that that piece of the graph has to be above the x-axis. If I look at pieces of this graph though, kind of figuring out where above the x-axis this is going to be, notice that if I looked at the slope of the tangent line here, this is pretty steep, right? But as I'm coming up, it's getting not as steep. So these are going to be bigger. Our derivative is going to be bigger at these values. And then notice over here, you know, it's going to be smaller and smaller. And so this kind of actually levels out. And so it's going to be going down towards 0. So our x values here, their y values of the derivative is going to be huge. And as we start to come in, we're going to start getting smaller and smaller. The slope is decreasing. It's not as growing as fast. And so we'll get something that looks like this for that piece. And so this is our derivative function, f prime of x. And then just want to make sure on when it says to find the average rate of change, you know exactly what you're doing. So if it says find the average rate of change of the function over the interval. So So I have y equals the square root of 4x plus 1 between x equals 0 and x equals 12. So we're trying to find the average rate of change. Basically, we're looking at the slope between these 2 points. If we joined the points on the, plotted these points on this function and then drew a line, we're looking at that slope of that line. And so we need to look at what's happening when x equals 0. We need to figure out what y is. I'm going to call this f of x instead, just so I can use. So we need to look at f of 0. So going in here and plugging in 0 wherever you see an x, we get this is equal to 4 times 0 plus 1. So this is the square root of 1, which is 1. So we have a point at 0, 1. We also need to find f of 12. So wherever we see an x, we're going to go in and plug in 12. So 4 times 12, that's 48. And 48 plus 1, that's a 49. And the square root of 49 is 7. So we have a point at 12, 7. So finding the slope between the 2 points. So the change in our y value, so 7 minus 1, all over 12 minus 0. So we have 6 over 12, or 1/2. So the average rate of change between those 2 points is 1/2. We didn't look at or forgot to do an example of infinity, going to infinity. So if we had the following, so the system of population of a culture of tumor cells is given by the following. P of t is equal to 3,500 t all over t plus 1. So find and interpret the limit as t goes to infinity of P of t. Okay, so we're looking at the limit, we're plugging in infinity. The thing is that we're going to get infinity over infinity, and that was another one of those indeterminate forms, and that's where we had to manipulate it. And so to manipulate this, one way to do that is looking at the highest degree of a term in the denominator. And so the highest degree, well, the term with the highest power is just t. And so our trick is to multiply this by that fancy 1, and it's going to be 1 over that variable to the highest power in the denominator. So we're going to multiply by 1 over t in the numerator, all over 1 over t in the denominator. So if we do that, you know, the limit t goes to infinity. Well, notice that our t's are going to cancel in that numerator. So all we're left with is that 3,500 all over, well, this has to distribute. So t over 1 over t, or t times 1 over t, t over t is 1. Plus, well, nothing cancels here, so this is 1 over t. So recall, if you have your denominator blowing up faster than your numerator, 1 over or a number over something blowing up is going to 0. So this 1 over t piece is going to 0, and we're left with 3,500 all over 1. Okay, so we found the limit. Now it wants us to interpret the limit. And so again, this was the population of a culture of tumor cells, and which is correct. The number of tumor cells gets closer to infinity as time increases. Well, as time increases, this is going to some number, so it's not going towards infinity. So that's not right. The number of tumor cells gets closer to infinity as time decreases. Well, right here, this is telling me t is going to infinity. Time is increasing, not decreasing. So that can't be it. The number of tumor cells gets closer to 3,500 as time increases. That looks like the correct answer, but I want to just make sure the other one doesn't look right. So the number of tumor cells gets closer to 3,500 as time decreases. No, that's not right, because time is increasing. So in this case, it would have been letter C. The tumor cells gets closer to 3,500 as time increases. Okay, so any questions from you guys? Let me just pause this. So we've just been spending the last 10 minutes kind of playing Jeopardy and going through some questions. And this is the last one that just popped up. And we're looking at the limit as u goes to infinity. And here was another one that we looked at if you wanted to pull that out. But the limit as u goes to infinity of 4u to the 4th plus 5 all over u squared minus 2 all times the quantity in the denominator 2u squared minus 1. So notice if we plug in infinity wherever we see a u, you get something in the form of infinity over infinity. And so that doesn't tell us anything. It's the indeterminate form. We got to go in and we got to manipulate it. And so but if we expanded this out, I noticed that I would have the biggest power, term with the biggest power in the denominator is going to be a u to the 4th. So if I expand this out, this is a 2u to the 4th. This would be a negative 1u squared and a minus 4u squared. So this is minus 5u squared. And this would be a plus 2. So again, infinity over infinity, that's where you wanted to manipulate. And in this case, we can divide the numerator by the variable to the highest power from the denominator. So we're going to divide every single term by u to the fourth. So 4u to the fourth, all divided by u to the fourth is just 4. Plus nothing cancels there, 5 all over u to the fourth. Distributing it in the denominator, 2u to the fourth over u to the fourth is just 2. Minus 5u squared over u to the fourth, that simplifies as 5 over u squared. Plus nothing cancels, so 2 over u to the fourth. So if the denominator blows up and the numerator does not, it goes to 0. And so we're left with 4 over 2, which is just 2. Okay, so it looks like we're all winners because we tied. Let me see. Because that one was 500, right? Yep. Okay, so this is pretty much, we're out of time, so we'll stop playing. But again, you have a test on MyMathLab this weekend. It's opening up at 12 a.m. Saturday morning, and then it's closing at 11:59 Sunday evening. So you want to get it done. In between that time, you guys have 2 tries. So if you don't like it the first time, you can always go back in and retry it. You're going to have to, but if you retry it, you're going to have to do all the problems again, and it's going to scramble them up for you guys, the order. But you might want to look at, because you're not going to be able to get back into that and review that test until after the due date. So if you wrote down, and you need to write down how to do problems, especially if you have to show work and you need to do it in a nice, neat manner, or you're going to get points docked off, and upload those to a Canvas assignment that says written work for Chapter 3 test on MyMathLab, fall 2020. So that's what you'll see in the MyMathLab. I believe you have to actually go in there through Canvas itself. It won't show up. So I think there's other ways to get around it, but so you're just going to go to the MyLab and Mastering and sign in that way and go to assignments. I'll put it at the top of the page, but you might not see it that it's there until, like I said, 12:01 or 12 a.m. on Saturday. And then once you're done with it, and if you're happy with that score you got and you're not going to retake it, then upload that assignment as soon as possible within like 15, 20 minutes to that Canvas page. And you're going to get points on the points for the written work. I'm not going to go through and grade it. I will when you guys take tests in class, but MyMathLab will grade it for you. And so that will be pretty much your score for that exam. But the portions where you guys are taking tests at the end of chapters on MyMathLab, I'm going to average all of those exams, and that's going to be weighted like one test at the end of the semester, like one that you took in class. So if you don't do too well on this one and you retook it and didn't do too well, it's an average of all the end of the chapter tests for one score, like a test for these. So, question.
Yes, I just want to make sure I understand. So we have them from, we just have one day, or we have all day Saturday and all day Sunday?
So basically all day Saturday, all day Sunday. The other thing, when you guys get in and do it, it's timed and you have a set time. And so, you can't leave it and come back. If for some reason your internet goes down or something happens and you're knocked out of the test, it will let you come back to the test, but it won't show you any of the problems that you had seen before or worked on. So you'd be able to get into problems that you hadn't opened up before. So just plan on when you're just sitting down to take it that, you know, I have this hour and a half to do it. I'm just not, I have like 30 or 45 minutes. I'm going to try to get this done because, again, it's timed and it won't let you go back in. And then we need to be thinking about when is the next, or when is the next, you haven't had one yet. When is the test going to be that is in the classroom? And it should be within the next few weeks is what I'm thinking. Let's talk about that on Monday after you guys took this test and figure out, and let's come up with a date. I'm open because we're pretty much just gonna take whatever we've been covering up to that point that we take the test, and it will be over all of that. So, but you're having 2 of those types of tests in the classroom, and then you have the final. And so it's probably a good time now soon because we're probably about almost halfway done with a semester. I don't know, 7 weeks out of 18, not too close. So maybe the halfway point, 9 weeks would be good. Okay, but we'll come up with a date in particular and maybe come up with a date for that second test. I have the date for the final, and that way you guys have it in your schedule and you know, and you can work around it. Or if for some reason they're telling you have to work on that day, you can maybe just get those hours off. Okay, so let me pop the video.
And then somebody had asked how many questions